consider the polynomial function f of x is equal to 3x squared times x minus 9 times x plus 7 squared. Now we're asked here to find all the zeros of this polynomial function. And then, in part B, we're asked to find the multiplicity of each zero, and then use the multiplicity to describe the behavior of the graph at each one of its zeros. So, part A, find the zeros. So how are we going to find the zeros? Well, let's recall that in order to find the zeros, we need to set this function f of x equal to 0 and solve for x. So that's where we'll begin. We have our function 3x squared multiplied by x minus 9 multiplied by x plus 7 squared is equal to 0. Now, notice in the front here that we have a constant 3. That's not going to affect the zeros, so let's get rid of it. Let's immediately divide both sides of the equation here by 3. And so we see 3 divided by 3 cancels itself out to 1, leaving us with x squared multiplied by x minus 9 multiplied by x plus 7 squared is equal to 0. And so we have 3 separate cases that we're going to need to consider here. We have x squared is equal to 0. We have the case where x minus 9 is equal to 0. And then we also have the case where x plus 7 squared is equal to 0. So in case number 1, in order to solve for x, we need to remove the square. So to do that, we take the square root of both sides of the equation, which leaves us with x is equal to 0. So here is 1, 0. In case number 2, to solve for x, we need to add 9 to both sides of the equation. So we see minus 9 plus 9 cancels itself out to 0, leaving us with x is equal to 9. So here is another 0. And last but not least, we have x plus 7 squared is equal to 0. So in order to solve for x here, we need to remove the square. So we will take the square root of both sides of this expression. So the square and the square root cancel each other out, leaving us with x plus 7 is equal to 0. And then to isolate x, we'll now subtract 7 from both sides of the equation. We see 7 minus 7 cancels itself out to 0, leaving us with x is equal to minus 7. So here is our third 0. So, oops, we did it. We have the zeros of this beautiful polynomial function. Our 3 zeros are therefore x is equal to 0, we have x is equal to 9, and we also have x is equal to negative 7. Now keep in mind, because these are zeros, they're also x-intercepts. So if you want, you could alternatively write these zeros in their ordered pair form, 0, 0, 9, 0, and negative 7, 0. So they both mean the same thing, so pick your favorite notation and stick with that. So, now that we have these zeros, we need to think about the multiplicity of the zeros and how this will affect the behavior of the graph at each one of the zeros. So in order to really understand the multiplicity, we need to identify what are the factors of this polynomial expression. So I'm going to expand this out. So we can see we have x squared, so that's x times x. Then we have the binomial x minus 9. And then we have x plus 7 squared. So we can rewrite this as x plus 7 times x plus 7 equals 0. So what are the factors that you see? Well, we certainly see a factor of x. And how many times does this factor appear? 2 times. The factor x appears twice. Now, what's another factor that you see? X minus 9. X minus 9 is another factor. How many times does this factor appear? Once. So this factor appears one time. And last but not least, do you see any other factors? We sure do. We see the factor x plus 7. And how many times does this factor appear? Twice. So the hard work is done. What we've done here is we've actually identified the multiplicity. So with factor x, we see that this factor appears 2 times, which means that this factor has a multiplicity of 2, which is an even number. Now with the factor x minus 9, we know that this factor appears once, which means it has a multiplicity of 1. Now 1 is an odd number. And last but not least, with the factor x plus 7, we know that this factor appears twice, which means that it has a multiplicity of 2, which is an even number. So we've identified the multiplicity of each factor, and now depending upon if the multiplicity is even or odd, we can then determine the graph's behavior. So we'll start here with our even multiplicities. We know that x has a multiplicity of 2, and that x plus 7 also has a multiplicity of 2. So we can conclude that therefore, since x, the factor x, and the factor x plus 7 have an even multiplicity, this lets us know that the graph is going to be tangent to the x-axis at these zeros. So because the factor's multiplicity is even, the graph is tangent to the x-axis at x equals 0 and at x is equal to negative 7. So even multiplicity implies that the graph is tangent to the x-axis at the corresponding zeros. Beautiful! So now we also need to go ahead and think about the results for the factor x minus 9, which has an odd multiplicity. So we can conclude that therefore, since the factor x minus 9 has an odd multiplicity, by definition, this lets us know that the graph is going to cross the x-axis at the 0. So the graph is crossing the x-axis at the 0, x equals positive 9. So this is because this factor has an odd multiplicity, a multiplicity of 1. And so there you have it. This is our beautiful final answer.